Welcome back, guys. I hope you had a good break. You always need to just get up, get those muscles going, get the oxygen flowing. We can't just sit and just take in stuff. We've got to allow our brain, right, to take in all the oxygen. Remember what we focused on today? We're looking at why are microorganisms so important in the environment. And we had a whole look at how we use it, the foods that we eat, how they're important in the environment. Now we're going to have a look at some of the questions that we can ask using these different concepts. Okay, you'd always like to start off with the multiple choice. The answers are there, so it takes a little bit of pressure off. And our question is, the use of antibiotics, remember that's what we looked at today, it's one of our biotechnology, is an effective treatment for. And now it gives us a whole variety, right, of answers. The first one, viral infection. And we say no, right, because remember, I'm going to say it over here, antibiotics, we need to jump to that concept that antibiotics are used for bacteria. All right, question number B, all right, is bacterial and protist. So although the bacterial is right, it's only bacteria. The protists, that's going to be your malaria, and that's not, we're not going to use antibiotics there, we're going to use different kinds of medication. So B is incorrect. C, bacterial. Yes, we know it's bacterial. However, we've already ruled out that viral is incorrect. So C has to be incorrect. Question or answer number D, bacterial infections only. Yes, right? That is our answer. Our answer is going to be number D because we're going to use antibiotics for bacterial infections. Okay, guys, our next multiple choice question is about vaccines. Vaccines are effective in protecting the body because, again, why are vaccines so important? What do they do? Right, number A, they trigger the immune system to produce antibodies. Yes, they do. And to protect the body from disease-causing agents. Yes, they do. So what we're going to do is we're going to leave number A. Looks like it's probably the correct answer, but I need to carry on with the rest just in case there is a more correct answer. Number B, they detect disease-causing agents as soon as it enters the body. No, guys, they can't. They've got to take a while. They've got to recognize it. So it's not going to be number B. Number C, they help the body excrete. No, excrete means that's urine or sweat. You can't excrete a disease-causing agent. Okay, so the terminology there is also totally incorrect. The next, number D, allows the disease-causing agents to multiply. Oh, no, 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 no. That's the last thing we want them to do, is to make more of themselves. So number D, all right, is definitely correct. Which leads us back to our very first answer, A, which we thought was correct. We just double-checked, and our answer then would be A. Okay, our next question also is a multiple choice question, and this time we have a diagram to go with. The question says, the diagram below illustrates activities taking place in the human body. All right, guys, so if we have a look at the questions that we asked, right, vaccinations, antibodies. So that's the word we are concentrating on, and antibodies, all right, is C. So that's the letter that we want to most probably be the answer. Let's look at our options though. Number A, structure A only. Now, structure A is the white blood cells, and we know no. We're looking for antibodies. Structure B only. B is the antigen. No, we're not looking for that, all right? The antigen is already what is on the cell, and that's what the virus is looking for. Do I connect? So definitely not. Number C, now we're looking here for the first time. Structures A and C. Now I said A only was no, But now I've got C over here, which means antibodies. Yes. Now why would A be correct? Because if I have antibodies, I also want to increase my white blood cells to come and destroy. All right, so yes, this is looking like the right answer, but I'm going to go to number D because it structures A, B, and C. But guys, it can't make number B. It doesn't make the antigen. The antigen is already, all right, on the cell. So we are going to look, D then becomes incorrect. So our most correct answer is going to be number C. Okay, the next question, lots of questions on this section in microorganisms involve some kind of reading piece. And the question here is on penicillin. Right, so we see penicillin. Why is it a microorganism? We know it's a fungus, and we know, right, it was an antibiotic. So now let's read what it says. Penicillin was discovered by a scientist called Alexander Fleming in 1928 while he was working with bacteria growing on a nutrient medium, agar. That's what you use for bacteria to grow. He noticed that on one of the plates there was a fungal growth. Around this fungal growth was a clear area where no bacteria were growing. And I'll show you the diagram that attaches there. The bacteria had been affected by something. Remember 1928, they weren't quite sure what this was. That had been released by the fungus. The fungus was identified as Penicillium. Okay? Tests showed that Penicillium was not toxic to humans. Some people are allergic, but most people it's okay and could be used to treat bacterial infections. Okay, here is his famous plate. There is the fungus at the top, and obviously if you have a looking at the clear area, that clear area over there, no bacteria, fungus was able to stop bacterial growth. Okay, so let's look at the questions. Give the generalized term used for medicines such as penicillin. What do we call those today? Those are called antibiotics. Right, remember we don't use penicillin. There's a variety of ways that pharmacies can now manufacture these antibiotics. Name 2 diseases that can be treated by using penicillin. So guys, we are looking, all right, for any 2 bacterial diseases. Now let's go back to the bacterial diseases that we looked at when we looked at our diseases in the previous one. The first one, most important that we looked at TB. Now the other one that we looked at was cholera. All right, I don't know if you guys can remember when we drank water that was filled with bacteria that gave us a runny tummy, etc. Right, a few other things. You can think of any bacterial disease. Some of you, right, might think of pneumonia. That's what you get, right, in your lungs, a bacteria that grows in your lungs. So any 2 diseases, but they must be bacterial. You cannot tell me HIV. You cannot tell me chicken pox. You cannot tell me all of those because those were all viral. So we're looking at any kind of bacterial disease there, and only 2. Okay, in some areas of South Africa today, TB medications, guess what, guys? The very next question actually gave you the answer. So if you were wide awake and you forgot about something, you're like, oh, okay, it gave me one. Are not curing some patients of this crippling disease. Why do you think this is the case? We spoke about it earlier. We spoke about this concept called antibiotic resistance. That is when bacteria, certain bacteria, do not respond. All right. They do not respond to antibiotics. So we can't stop them, and they keep on multiplying, and they can make us sick. So this is, what do you think? Why do you think this is the case? And it's called antibiotic resistance. Now the next question asks us, remember we often ask you about the management of a disease. What recommendations would you give a TB patient about taking their medication? Okay, guys, when it comes to TB, remember, right, how do we stop resistance? Very simply, complete the course. Right, you cannot stop midway. You've got to make sure that you finish. And when it comes to TB, finish all the antibiotics, right? Anytime, not only TB, any kind of antibiotics, you must always finish the course, because what you do then is you kill all of the bacteria and you don't allow some to stay behind and the ability of that mutation to take place. So what would you recommend? All right, complete the course, you finish it. You don't stop when you feel better. That's the biggest problem. They stop when they're feeling better, then they stop the medication and the bacteria is not, all right, has not been taken care of. This is a bit of a tricky question. You've got to pay attention here and you've got to look at your diagrams very carefully. Okay, let me read first and then we'll go and we'll look at the diagrams. Each of the dishes in the experiment was streaked with 5 different types of bacteria, A, B, C, D, and E. Now I'm going to go to the diagram now because otherwise we're going to get confused. I want you to have a look at this. All right, so the A, the B, the C, the D, and the E, those 5 arrows are the bacteria. All right, so guys, that is really important. Then what you have, let's go back. A strip, one strip containing 4 different antibiotics, P, Q, R, and S. So that strip that you see across here, that strip in each of those, all right, that I'm going to put here an A, so your big capital A, so that you know that that strip is A for antibiotic. So each of them have got 4 strips of bacteria, and the dark black strip, that is going to be the antibiotics. Okay, and was then placed across the center. We saw that. The diagram shows the results after incubation for 3 days at 37 degrees. What do we know 37 degrees? All right, body temperature, and that is the ideal growth for bacteria. Okay, so here we've got, all right, here we've got the diagram, a little bit confusing, but let's read the questions. Which antibiotic was the least effective? Now, what are you looking for? You are looking for the antibiotic that grows over, all right, grows over the strip. So which antibiotic was least effective? Here we had B and D, C, D, and E, B and C, and B and E. Which antibiotic was the least effective? So if you have a look here, which this one had 1, 2, all right, this one 1, 2, this one 1, 2, but this one had 3 bacteria growths. So which one was it? Antibiotic number or letter Q. Right, it let 3 go. Which type of bacterium was sensitive to all 4 antibiotics? In other words, which one did which A, B, C, D, or E did antibiotics kill everywhere? I want you to have a look. Look at A there. Look at A there. Look at A there. So the bacteria that was easy to clean, and we used a small a because that was the letter that we used. Guys, which type of bacterium was the most resistant to all of the antibiotics? In other words, which one did grew the most. So if we have a look, it says it was most resistant. So here, if we have a look, what did we have? B and D, C, D and E, B and C, and B and E. Have a look. B appears 3 times, so that means the antibiotics didn't, all right, cure it at all. Okay guys, I'm afraid that's all we have time for today. I hope you have a greater understanding of why microorganisms are so important in our environment. Until next time, cheerio, bye.